Welcome to Sundar's lecture. This is lecture number 24. And what are all the topics we have seen in the last class? We have taken a problem, that is example number 4, and we have found what is the power delivered by the independent source. Independent source means here it is 15 volt source, and we have also found what is the value of R1 and R2 in the given circuit. Right? This is what we have seen in the last class, and in today's class we will take another problem, and this is the last problem in dependent sources, right? So we will start a new topic in the next lecture. Anyhow, because this is very important, this dependent sources and applying KCL and KVL at the same problem gives you much more insight to the problems or approaching the electric circuits, right? That is why we are taking this much of example problems so that you can easily understand the concepts of KCL and KVL and also uh, dependent sources, right? So see, in this problem, what is the question asked? Find the current delivered by all sources, which means you have to find what is the power delivered. See, sorry, here it is, I have written I have written wrongly. See, this is not a area. Okay, so this is not current, actually it is power. So this is a question is find power delivered by all sources. See, if you want to find what is power delivered, see, it is very important to understand what is power deliver or power absorb. This topic, this particularly this power delivering and power absorbing things we have seen in the uh, initial lectures. Please go through my initial lectures to understand the basic idea about power delivering and power absorbing. Anyhow, power delivering means the current from the source has to be, the current should travel from minus to plus. That is very important. That is very important, right? So you see, we will write the expression to find what is the power delivered by, first of all, this 20 volt source. So I will write that as P20 volt, P20 volt, right? So P20 volt is what? See here, it is V1, voltage across this 20 volt will be V1. That is what given. See, this V1, V2, V3, and this is actually V4, this is V5. These all things were given already in the question itself, right? This is I1, I2, everything is given in the question. So we can easily write the expression. It is very simple anyhow. So this is V1. So we will write, anyhow we can also write 20 since it is directly known that is it is a 20 volt. Anyhow, we will write it with the expression. So V1 into, what is the current flowing from minus to plus? See, it is very important to understand. Current should flow from minus to plus, since the question asked is power delivered, not power absorbed, right? So power delivered. So it is traveling from minus to plus, right? I1 is traveling from minus to plus, so it will be I1. That's all. So this is expression number 1, right? So power delivered by 20 volt source. See, what is this source? That is, this is actually a current source, right? This is actually a current source that depends on some other voltage. That depends on V1 voltage. See, this is V1, right? So I will write this as P 8 mo V1, which is nothing but, you see here it is given like this. What is the meaning of this one actually? What is the meaning of this 8 mo V1? See, I will write here. It is, you have to understand, or it should be very clear. So this is actually V by 8. That's all. It is actually V by 8. Current in this branch is nothing but V by 8. That you have to understand it clearly. Right? See, this is actually 8 more. That means it is given as 8 into V1, right? So 8 into V1, not V1 by 8. Anyhow, this is actually V1 8. 8 into V1, right? More, which is nothing but, this is actually current source. So they have given it in the more values, right? So I will write here that should be equal to, so what is the voltage here? This is V3, right? V3. voltage will be is equal to across this source, that is V3, and what is the current? Current, which is nothing but it is I3, right? I3, and it is also a current source. If you find what is the value of current source, then that is nothing but I3. So that should be multiplied by I3, because see, this is flowing from plus to minus here. So you see, 1 minute. See, this current is flowing from plus to minus. Try to understand, right? This is flowing from plus to minus. What I have told you, they have asked you to find what is power delivered. Power delivered should be what? It should the current should be travel from minus to plus. The current should travel from minus to plus. Anyhow, so what I will write here, anyhow I will take it as I3, but I will take here, it should be minus I3. Minus I3. This is expression number 2. That is why I am telling you from the beginning. So you see, next source, it is this voltage source. That means current dependent voltage source. So I will write here P 2 ohms, P 2 ohms, I2 source will be equal to, what is the voltage? That is nothing but V4. We can directly write this is V4 into, you see again, current I4 is traveling from plus to minus in this source. So what you have to do here? Obviously you have to put minus I4, minus I4, which means what we are actually telling, don't travel like this, travel like this. So if it is traveling from minus to plus, then it should be power delivered, right? So power delivered, while writing the expression itself, you have to be very clear in the writing, in the power delivery expressions, right? Power delivery expressions, right? Now we need to find what is V1, I1, V3, I3, V4, I4. That is our ultimate aim, right? So for that, what I will do, I am going to apply KCL and KVL at some points, right? So we will mark the points first of all, so that we can easily do. See, this is A, this is B, this is C, D, and it can be written as E. And you see, every points here, everything is same. So what I will write, this points as center point. Every point here it is O. So this is A, this is B, this is C, this is D, this is all points will be O. Right. So what I will do now, see, we know here it is given V1 is which is nothing but what, it is 20 volt. So V1, which is nothing but it is 20 volt, it is given, right? So what we can do now, we can write a KVL expression for this loop, ABO, ABO. So if you write KVL at ABO, so write KVL at ABO. So what we can do now, so start from this point and you write the expression like this. So if I start from this point, I have to travel from minus to plus in the voltage source. So it will be plus 20 volt, plus 20, and I have to come like this. You see, I have to I am traveling in this direction, but this current, you see, you don't need to see this current. Why? Because it is in the voltage source. In the voltage source, you don't need to see any current in while writing the KVL expression, right? So you see, if I come here, because here it is a resistor, I have to consider this current, that it is in the same direction. So I have to put minus 2 into I2, 2 into 2 into minus 2 into I2, and that's all, right? And that's all, right? So that should be equal to 0. See, it is very simple. So if I simplify this expression, I will get what is I2 also. So I will write here, this is not volt, this is actually 20, right? So if I write here, so 20 should be equal to 2I2. So what is this? I2. So I can directly write I2 should be equal to, if I divide this by here, it becomes 10 amperes, right? So I2 becomes 10 amperes. I2 becomes 10 amperes. With this, we can easily write, see, between these 2 points, it is 20 volt. And what is between these 2 points? It is actually connected parallelly, right? So V2 also it has to be what? 20 volt, right? So how it can be? Anyhow, by expression also we can write this V2 should be equal to 20 volt. Anyhow, I will write here. You see, if I want to write what is V2, I have to travel from this point to this point. See, minus 2 plus, right? From minus 2 plus I have to travel. If I travel, right, I have to write expression for V2. I have to write expression for V2. I have to travel in this direction. So if I travel in this direction, it is coming opposite to me. So what the if you have to write 2 into I2. And what is I2? 20, 2 into 10, 2 into 10, that is nothing but 20. So obviously V2 should be what? 20 volt. V2 should be what? 20 volt. Obviously it has to be 20 volt, right? So you see, I will write here. So V2 and I2 have been found, right? Now what I need to do, I need to find what is this I3, because I3 is not given directly. Somehow it is depend on the V1 voltage source. So it is very easy also. See, I3, if I want to find what is I3, I3 should be equal to 8 into V1. We know that. That is what given here. 8 into V1. What is V1? V1 is given, right? It is 20 volt. It is obviously what? So 8 into 20. So obviously I3 should be what? I3 I3 should be equal to 160, right? 160 amperes. That should be 160 amperes. That we know. So you see, now we know what is I2 and what is we know what is I2 and what is I3, right? So you see, it is very simple now to find what, because we don't know what is I1, right? Since we have not find what is I1. So if you want to find I1, what you do, you apply KCL at this point B. So you see, I am going to apply KCL at B. If I apply KCL at B, see, I1 is coming in, I2 is going away, I3 is going away. So I1 is only coming in, I2 is going away, I2 is going away, and I3 is also going away. So this is the expression if I apply KCL at point B. So you see what we can do now. You know what is I2, what is I3. So that you can easily find what is I1. So that should be equal to 160 plus not I2. I2 is 10 amperes. So you see it is I2 is 10 amperes plus I3 is 160. So you can easily write that I1 should be equal to 170 amperes. So this is I1, right? So I1, we have found what is I1. So now we have found I1, V1, V2, I2, I3, right? Now what we can do, we try to find what is I4 and we need to find what is V4 and what is the value of V5. That we need to find, right? We try to find that, right? So first for that we need to find what is V4. Since what is V4, you see it is 2 into I2. We know what is I2, right? We can easily substitute here. So I will write here V4, that is already given. V4 should be equal to 2 into I2. That is given. This is dependent current source. And I know what is I2 now. So you can easily substitute here. So 2 into 10 ohms. That is 2 into 10 ohms, right? That is what we have found here. So obviously, what is V4? V4 should be equal to what? 20 volt. Right? By this, I have told you here, see, this is connected parallelly to this branch. So V1 should be equal to V2. That is what we have got. V1 is equal to 20 volt and V2 is equal to 20 volt. Obviously, if this is V4, then this is actually connected parallelly to this circuit. And obviously, V5 should be 20 volt, right? So it is not necessary to write the expression and get the V5. We can directly write V5 should be equal to 20 volt. This should be understood default. That is the thing you have to. That is the approaching electric circuit will be easy if you practice it perfectly, right? Anyhow, we have found what is V5 and we try to find what is I4 and I5 now, right? So if you want to find what is I5, see it is very simple now. What we can do, we can write what is V5. What is V5 here? So if you want to write what is V5, see V5 should be equal to, you travel from minus 2 plus so that you can get V5, right? So if you travel from minus 2 plus, what you will get? So you have to travel in this direction. This current is coming opposite to you. So it should be plus 5 into I5. So plus 5 into I5. We already know what is V5, right? So it is very simple now. So I5 should be equal to, what is V5? That is 20 divided by 5. So what you will get? I will directly write, right? So it should be, I5 should be equal to what? 4 amperes, right? 4 amperes. So we have found what is I5. Now you see, you know what is I3 and you know what is I5. So you need to find what is I4. Very simple. How? How? See, I can apply KCL at point C. Since I know what is I3 and I5, I can easily find what is I4. See, I will write here, apply KCL at node C, right? At node C. If I apply KCL at node C, I3 is coming in, I4 is going away, I5 is going away. So what I can write? So I3 should be equal to, I4 plus I5. Since I4 and I5 are going away, so I can write like this. Anyhow, if I substitute these two values here. I3 I know, right? I already have found what is I3, that is 160 amperes. So I can write here, this is 160, which should be equal to I4. I don't know what is I4, right? So I4 plus, what is I5? I5 I have found, I5 I have found 4 ohms. So this should be 4. So obviously what? I4 should be equal to, so if I minus this, 156 amperes, right? So it should be 156 amperes. So you see, we have found all the values now. We know what is I1, I2, I1 is I1, I2, I3, I4, I5, and this is V1, V2, and you need to find what is V3, because you see, we don't know, we have found V1 is 20 volt, V2 is 20 volt, V4 and V5. All the values we have already found. So for that, what I can do now, I can write a KVL expression. KVL expression for this loop. Since this is V2, this is V3 and this is V4, right? It is very simple now. So you see, I will write KVL. Anyhow, I will write here KVL at BCO. So what I will get? See, start from this point. So this is V2, right? So minus 2 plus. I have to travel from minus 2 plus in V2. So I can write this is plus V2 and I have to travel in this direction from plus to minus in V3. See, I have to travel like this. So minus 2 plus, that is V2. It is here plus 2 minus. So it has to be minus V3. It has to be minus V3. And you see, I have to travel from plus to minus again in V4. So what is this? This is minus V4. And that's all, right? That should be equal to 0. So that should be equal to 0. So you see, if we want to find what is V3, so V3, so you just bring V3, because I don't know what is V3 to other side. So V3 should be equal to V2 minus V4. What is V2? V2 is 20. What is V4? V4 is also 20. So obviously then what? 20 minus 20, that should be equal to V3 should be equal to 0. V3 should be equal to what? 0. Now you see, we have found all the values, V1, V2, V3, V4, V5 and I1, I2, I3, I4, I5. All the values we have found. Now what you do, you just substitute in this expression to get what is the power expressions, power delivered by the sources, all sources, right? For that we will take a new page. See, we have taken this. See, we have taken the expression. So we try to substitute in this expression right now. So P 20 volt should be equal to, what is V1? What is V1? That is 20. V1 is 20. And what is I1? I1 is 170. I1 is 170. So 20 and 170. So here I need to substitute 20 into 170. So final answer, P by 20 volt should be equal to 3400 watts. 3400 watts. So this is the final answer. Next thing, I need to find what is P by this 8 VI source, right? So P by 8 mho V1 source should be equal to, what is V3? So V3 V3 is 0. Obviously it has to be 0, right? So you see V3 is 0. Whatever the I3 it may be, that is not going to create any problem here. Since V3 is 0, so you have to substitute 0 into minus I3 will also give you what? Obviously it has to be P8 mho V1 should be equal to 0 watts. That is because V voltage across the source is 0, so obviously power delivered by this source should be 0, and then it will be P2 volt. So I will write here. So P2 ohms I2, that should be equal to V4. V4 is what? V4 is 20 volt. Everything is 20 volt, right? So this is 20. V4 is 20. And what is I4? I4 is 156 amperes. I4 is 156 amperes. So I will substitute here. It is 20 multiplied by, this is 1. What is the value? I4 156, right? So 156. 156. So if I simplify this, what I will get? P2 ohms I2 should be equal to minus 3120 watts. Minus. Then what is this minus actually telling us? See, this minus is actually telling us this source, which means uh, this source is not delivering power, it is absorbing the power, and this source we are getting it in positive value, see 3400, it is actually delivering power. And what happens to this source? This source is not delivering or absorbing power, the because since the voltage across this point is 0, it is 0, right? So it never delivers the power or absorbs the power. Anyhow, so this is the final value. See, we will wind up the dependent source problems with this lecture, and we try to uh, see a new topic in the next lecture. You go through this dependent problems very clearly, so that we can easily solve the gate questions, right? If you have any doubts, you please post it in the comment box. I will reply for the questions, right? Thank you. We will see in the next class with a new topic.